Hey guys, you did an awesome job today investigating the distributive property. So we're just going to have a little bit of practice today and see how well we understood these ideas. So I've just got over here what I'd call a generalization of it. This is kind of where you use variables to represent patterns and relationships without actually referring to a specific question. So I've just sort of got A, B and C, and I've put them in the position of the variable and the number terms that we've been working on. I'm just going to show you here. I often put these loops in like this to show distributive property. We have A times B. Our first term is AB. And of course, A times C, the second term. So we have AC there. So there's a nice little generalization of the distributive property. Okay, now let's have a look at these examples. These are some nice basic ones, so until we get comfortable with it. All right, using the distributive property, it says expand. Another word for expand means really do the multiplication, multiply out. So the first thing I'm going to do here is put my little distributive property arcs. So when I do that, I've got 4 times 2a, 8a, and 4 times a positive 5 is positive 20. So we've got 8a plus 20. All right, let's have a look at the next one. I'm going to put my distributive property there. We have 3a times 6a. Oh, we're going to have to use some of our knowledge of multiplying here. So let's take the coefficients. 3 times 6, we've got 18, and then a times a, we've got a squared. And then we've got 3a times negative 1. We've got minus 3a there. All right, let's have a look at our next one. Oh, I don't seem to have a term out the front. Well, there actually is. That hidden term is 1. So I've actually got negative 1 here. So I'm going to do the same thing. I'm going to put my distributive property arcs. So let's do that. We have negative 1 times 4m. Let's multiply the coefficient with the constant. We've got negative 4m. Negative 1 times positive 6, and we've got negative 6. So have a look at that. We have a 4m, a positive 4m and a positive 6. We have the negative out the front. It's basically made both of those terms negative. All right, and our last one, a little bit trickier one. Once again, a term out the front multiplied by 2 terms in the parentheses. So let's put our distributive property in there. Oh boy, this is a tricky one. Let's do our coefficients. Negative 5 times 2. Going back to our integer work, we've got negative 10 there. A times a, got a squared. B, we haven't got another b there, so we just tag the b on there. So our first term is negative 10a squared b. All right, let's do our next one. Negative 5 times negative 3. Oh, remember our negative. We've got a positive 15. A, is there any other a's here? No, so I'm just going to put my a there. And then we've got b times b. We can write b squared. Hey guys, let's have a look at some slightly harder ones this time. All right, this one says expand. So there's our distributive property, distribute, and simplify where possible. So when we see the word simplify, we often think of collecting like terms. So we've got to watch out for that once we do our expanding, our multiplication. Oh my goodness, look at this one. We appear to have not 1 distributive property, but 2. Now, of course, these are multiplies, so multiplication always comes before adding and subtracting. So let's go. We have 4a times 3. 4 times 3, we've got pen malfunction, 12a. 4a times negative 2a, well 4 times negative 2, negative 8, a times a squared. All right, now we have a plus 6a times a positive 3o. 6 times 3, so we've got a positive 18, a times a squared, and positive 6a times negative 1 have negative 6a. All right, so now that we have expanded there, let's look for our like terms. Oh, look, we have an a term here and an a term here. And we also have an a squared term here and an a squared term here. So let's have a look at collecting these. I'm going to put my little borders in, helps me. So we've got 12a take away 6a. 12 take away 6, we have 6a. Negative 8a squared plus 18a squared. Well, they are like terms. Negative 8 plus 18, using our number line, we get positive 10a squared. Remembering that we don't change the variable part at all. All right, let's have a look at this next one. This looks a little bit different. We have a subtraction here, but then of course we have our multiplication. Of course, order of operations, we've definitely got to do that multiplication first. So I'm going to bring down the bits that I'm not using. So I'm going to bring down my 10m because I haven't used him yet. Now let's distribute. Negative 2 times 3m, negative 2 times 3, negative 6m. And negative 2 times positive 4, we've got negative 8. So now let's look for some like terms. We have a 10m and a 6m. Oh, this poor little 8 hasn't got a mate. Anyway, he'll just stay there by himself. So now let's collect our like terms. 10m, take away 6m. We just add or subtract the coefficients. So 10 take away 6 is 4m. And we've got this negative 8, no friends to collect with, so we've just got 4m minus 8. All right, oh, look at this. This is a beauty. This is kind of a level 3 question. This is a little bit beyond what we would normally be doing. So let's go and have a look. We've got a subtraction, multiplication, an addition, multiplication, subtraction. We've got to do that multiplication before anything else. All right, so I'm going to bring down the things I don't need. I'm going to bring down that 25ab because I'm not doing that subtraction yet. Let's have a look here. Negative a times 3b, we've got negative 3ab, or negative 3ba, same thing. Negative a times negative 4b, so we have positive 4a squared. Positive 6a times b, we've got a positive 6ab there. Positive 6a times negative 2, we have negative 12a squared. And I'm going to bring this down. We haven't done anything with the little negative 3a. Let me bring him down. All right, oh my goodness, too many terms. Let me break them up so I can see it a little bit clearer. There we go. So now let's look for our like terms. Here we have an AB term or a BA. Doesn't matter which way those A and B are. So let's look for AB or BA terms. We've got one here. We've got one here. Any others? Oh, there we go there. And what other ones have we got? We've got positive 4a squared, a negative 12a squared. Oh, what about this little fella here? He doesn't have any partner, does he? So just a little a term all on his own. All right, now let's go and collect those like terms. All right, 25ab minus 3ab, there's 22ab, plus 6ab, we've got 28ab. And sometimes you might want to cross those out just to remind yourself when you've done them. Right, 4a squared, take away 12a squared. Well, 4 take away 12 is negative 8. So we've got negative 8 a squared. And our poor little fella, let's cross those off. Our poor little fella over here, negative 3. Got no one to collect with, so there we go. So this time we have 1, 2, 3 terms in our expression. Okay guys, let's have a look at a little application of where the distributive property can help us figure out problems. Here it says write a simple expression for the area of this shape. Okay, well, an expression we're talking about obviously an algebraic expression, so we're going to have algebra terms in it. And we want it simple, so that means where we can, we've got to remember to collect like terms. Okay, so let's have a little look here. My goodness, this is not a rectangle, not a triangle. Okay, well we could do this a couple of ways. I could, let's try this way first. I'm going to divide my shape up into 2 bits here. So I've got this area 1 and this area 2. So now we've got 2 rectangles. All right, so let's write our expression for area. We're going to find area 1 and then we're going to add to it our area 2. Okay, so we've got to get the length and width of our rectangle. Well, area 1, that's nice and easy, isn't it? We've got 5x times 4. I'm going to write that down. Area 1, 5x times 4. Plus our area 2. Well, let's have a look. Length, width. Oh, we've got our width here, 3, but we haven't got this length here. We've got to figure out what that is. Well, if this whole length here is 9x, all the way along here is 9x, and this length along here is 4, then what's this little bit remaining here? Well, we're going to find the difference between those two. So this little bit here is going to be 9x take away 4. So if we come over here, we have our length times our width. So we've got 3 times 9x minus 4. Here's our expression. We're going to go and simplify it. All right, so now that we've got our expression, let's simplify it. We've got 5x times 4. That's not a distributive property, that's just a standard product. 5 times 4, we have 20x there. Now we've got our distributive property. Oh, pen malfunction. Positive 3 times 9x, so we've got positive 27x. Positive 3 times negative 4, we've got negative 12. So there is an expression. Now we're going to simplify it if we can. Let's put our little dividers in. We've got some like terms here. There we go, so we can collect them. 20x plus 27x, we've got 47x. And our poor old little negative 12 hasn't got any other terms to collect with, so we just put him here. So here is a nice, simple expression for the area of that shape. All right, guys, I'd like you to have a look at these 3 and have a go at these ones for tomorrow. Question 1 says, expand and simplify where possible these 2 expressions. Here's a little application. It says, write a simple expression for the perimeter of this shape. Just a reminder that perimeter is the total distance around the outside. So reminder, that means they're equal. So opposite sides here are equal. This one and this one are equal, so we have a rectangle here. So we know if this side's 5, we know something about this side as well. If this side's 12x, we know something there. Could we perhaps use the distributive property here? Would that help us at all? Have a go. See if you can write a nice, simple expression for that area. All right, we'll talk about this when we get to class. Have fun.